Pluto, once considered the ninth planet in our solar system, is a distant and dim celestial body that has long fascinated astronomers. Although it was reclassified as a dwarf planet, recent and surprising claims by renowned astrophysicists Neil deGrasse Tyson and Michio Kaku have brought Pluto back into the limelight. According to their warnings, Pluto could be on a potential collision course with Neptune. This isn't mere speculation. They're raising genuine concerns that this small world might be heading toward a catastrophic encounter with one of our solar system's gas giants. But how could such an event even be possible? And what would happen if it did occur? Are we simply witnessing an optical illusion of cosmic proportions? Or is something real and potentially terrifying unfolding? Pluto's orbit is unusual and erratic, especially when compared to the relatively circular paths of the main planets. It takes Pluto 248 Earth years to complete just one trip around the Sun, and since its discovery in 1930, it hasn't even finished a full orbit. Adding to the complexity is its highly elongated and tilted orbit, angled about 17 degrees from the solar plane. One of the most intriguing aspects of Pluto's journey is that its path overlaps with Neptune's. For nearly 20 years during each orbit, Pluto is actually closer to the Sun than Neptune. This raises the obvious question: why haven't the two worlds collided? The answer lies in the intricate ballet of gravitational forces. The orbits of Pluto and Neptune are locked in a 3:2 resonance, meaning that for every 3 orbits Pluto makes, Neptune completes 2. This synchrony ensures they never actually get too close to each other. When Pluto crosses Neptune's orbital path, it's always at a safe angular distance, at least 90 degrees apart, thanks to what's known as asynchronous oscillation. Additionally, orbital drift plays a protective role. As Pluto moves through space, it often passes above or below the plane of Neptune's orbit, avoiding a direct intersection. Combined, these factors form a cosmic safeguard that has, so far, prevented disaster. Nevertheless, experts like Tyson and Kaku warn that even a slight disturbance in this balance, perhaps due to an unknown celestial influence or a long-term orbital shift, could spell trouble. If that balance were disrupted, Pluto's eccentric path might bring it dangerously close to Neptune, and the consequences could ripple throughout the solar system. Could Earth be affected too? While such an impact remains unlikely, the scenario underscores the delicate nature of planetary motion and the vast complexities of gravitational interactions. The so-called three-body problem, understanding how Pluto, Neptune, and the Sun influence each other, remains one of the most challenging puzzles in celestial mechanics. Ultimately, while Pluto is unlikely to crash into Neptune anytime soon, its strange orbit and the warnings from leading scientists serve as a reminder that our solar system is far from static. It's a dynamic and ever-changing arena where even small shifts can lead to colossal consequences. Another significant factor in this discussion is the VZK wobble, named after researchers Zell, Kai, and Kaku, who studied the spatial dynamics of celestial bodies. This phenomenon describes how 3 astronomical masses, like Pluto, Neptune, and the Sun, gravitationally interact and influence each other's motion. In Pluto's case, the VZK wobble helps explain the apparent irregularity in its orbit, especially when it's near the Sun. While Pluto's path may seem chaotic, this wobble actually contributes to its long-term stability. The VZK wobble illustrates that even in the seemingly unpredictable cosmos, underlying principles and patterns impose a degree of order. These gravitational dynamics ensure that Pluto remains on a steady course, avoiding collision with Neptune or deviating wildly from its orbital path. This 3-body interaction is vital to understanding how celestial trajectories evolve due to competing gravitational forces. By studying it, scientists gain valuable insights not only into Pluto's orbit but also into the mechanics of our solar system and distant galaxies. In the late 1980s, numerical models revealed that while Pluto's orbit is supported by stabilizing features, it remains sensitive and prone to variation over time. Tiny changes in initial conditions, such as its position or velocity, can lead to dramatically different orbital outcomes over centuries. Despite this, Pluto's orbit has shown remarkable resilience and stability over billions of years. Modern automated data and simulations have deepened our understanding of how the gas giants, Neptune, Jupiter, and Saturn, impact Pluto's journey around the Sun. Of particular note is the orbital resonance between Neptune and Pluto. For every 2 orbits Pluto completes, Neptune finishes 3. This synchronization plays a crucial role in keeping Pluto's path stable. But Neptune doesn't act alone. Jupiter's immense gravitational pull exerts a powerful stabilizing influence, and even Saturn contributes to this complex gravitational choreography. Research shows that Jupiter's sheer mass may be sufficient to help keep Pluto on a safe, consistent path for eons. Together, Neptune, Jupiter, and Saturn appear to cooperate in maintaining the balance that allows Pluto to travel safely through space. These intricate yet essential gravitational systems are central to preserving order in our solar system. Without them, objects like Pluto could easily collide with others or be flung into space, triggering chain reactions across the cosmos. This is why understanding Pluto's motion, especially in relation to Neptune, is so critical. It provides a clearer picture of the vibrant, ever-evolving nature of our planetary system. Pluto's orbit stands as a prime example of how seemingly erratic paths can reach equilibrium through complex gravitational and kinetic interactions. It also emphasizes the importance of continuous observation and analysis of such anomalies to better understand our place in the universe. Exploring the outer solar system often leads us to confront strange, unpredictable behaviors of celestial bodies, and Pluto exemplifies this. Its orbit reflects the concept of orbital chaos, where even minute changes in starting conditions can dramatically alter future outcomes. This sensitivity means that tiny deviations in Pluto's speed or position could significantly shift its trajectory over time. To decode these behaviors, scientists rely heavily on computer simulations. These models use advanced equations to replicate the gravitational interactions between Pluto, Neptune, and other bodies. By tweaking small variables in these simulations, researchers can see how slight differences lead to vastly different long-term paths. In the late 1980s, such simulations uncovered an intriguing truth. Although Pluto possesses stabilizing mechanisms like asynchronous oscillation and orbital drift, even small discrepancies in its starting point can produce surprisingly erratic motion. Yet, despite this inherent unpredictability, Pluto's orbit has remained stable over billions of years, highlighting the hidden order beneath the surface. In the end, forecasting celestial orbits, especially those as complex as Pluto's, remains a monumental challenge, but also offers a profound window into the dynamics of our solar system and the elegant balance that governs it. The unpredictability of celestial systems makes forecasting their far future behavior an immense challenge. While mathematical models are exceptional tools for decoding and estimating cosmic motion, they also expose our limitations. These models rely heavily on initial conditions, and even the slightest error or adjustment can dramatically alter the outcome, making exact predictions nearly impossible. Beyond the irregular nature of planetary orbits, Pluto serves as a vivid example of the ever-changing and dynamic nature of our universe. Despite the significant strides humanity has made in understanding the cosmos, Pluto's eccentric behavior reminds us of how much remains unknown. Studying how massive planets influence Pluto's movement deepens our understanding of the solar system's interconnected mechanics, showing how the position and presence of each planet can significantly affect the stability and trajectory of others. So why are respected astrophysicists now voicing concern about potential collision between Pluto and Neptune, even when cosmic laws are thought to prevent such disasters? Neil deGrasse Tyson, a renowned astrophysicist and vocal advocate for space science, offers a unique perspective on this planetary puzzle. Known for his role in Pluto's reclassification as a dwarf planet, Tyson argues that this shift wasn't a demotion but necessary refinement of our evolving understanding of the solar system. His views on orbital dynamics emphasize the need for constant learning and adaptability. He sees Pluto's chaotic path not as an anomaly, but as a symbol of how much remains to be discovered. Yet, Tyson's typically optimistic stance becomes more reserved when addressing potential for a Pluto-Neptune collision. His concern stems from Pluto's unpredictable orbit and the delicate gravitational dance it performs with Neptune. Though the two bodies have so far avoided catastrophe, Tyson warns that even minor shifts, amplified over millennia, could eventually lead to chaos or, in the most extreme case, a collision. While such an event would lie far beyond our current timeline, his cautious tone suggests a need for continued scrutiny of Pluto's orbit. Tyson isn't the only expert raising the alarm. Michio Kaku, a prominent theoretical physicist, also acknowledges the fragile balance of planetary motions and the unforeseen consequences that can unfold over vast timescales. Like Tyson, Kaku marvels at the beauty of the cosmos, but he also warns of the instability that may lurk within the apparent order. Both scientists underscore the importance of continued exploration and the need to understand the hidden forces driving planetary motion. In many ways, Pluto's story is a reminder that our understanding of the universe is never static. Each new discovery prompts more questions and deeper curiosity, though the chance of Pluto-Neptune collision remains slim and likely millions of years away. The mere possibility is a humbling reminder. Space is full of surprises, and even the most seemingly stable planetary paths can shift. Pluto teaches us to keep our eyes on the skies and to never stop seeking answers in the vast unknown.